going to go ahead and get started here. So let everybody log in. About 6:02 is when we're going to go ahead and get started. All righty, folks. So hello and welcome to this evening's Zoom webinar that's being produced by the Honors College at West Virginia University. This event is the second faculty fellow lecture taking place this fall semester. These lectures are designed to allow each Honors College fellow an opportunity to provide an inside look into the innovative course they are currently teaching within the Honors College and will be teaching next spring semester. I am Damian Clement, Associate Dean of the WVU's Honors College. Tonight's lecture is entitled Climate Change via Excel by Dr. Atheer Almasri. Dr. Almasri is a teaching assistant professor in the Fundamentals of Engineering program. We will follow our standard Zoom webinar format this evening after the presentation. After the presentation, we will host an open question and answer session. Since we're using the Zoom webinar platform for this lecture, before we begin, let me review some of the features that will allow you to experience this evening's lecture in the best way possible. If you have issues with your audio or video at any point during the webinar, be sure to check your personal Zoom settings and your computer volume controls. If you have questions, please use the Q&A function at the bottom of your screen. Due to enhanced security protocols, webinar attendees will not be able to see other questions, only their own. To ask a question, you must click on the Q&A button. A separate screen will appear, then you may type your question. The presenter will answer all your questions live at the end of the presentation. If live captioning has been requested, it can be viewed by clicking the CC button at the bottom of your screen. If captioning was not requested, a captioned version of the recording will be available at honors.wvu.edu. And now let's start this evening's lecture. So it's my pleasure to hand it over to Dr. Almasri. I'm going to stop my share here so you can take over.
Thank you so much, Dean Clement, for the nice presentation. And welcome everybody. I'm kind of intimidated because this is kind of the first time for me. I'm giving a lecture to almost 150 attendees. Hopefully it's going to be a very nice lecture and you guys are going to like the course. I'm going to start with, honestly, with my name. As Dean Clement said, my name is Atheer and I'm a teaching assistant to professor in the Fundamentals of Engineering program at WVU. And I've been actually teaching for almost the last 14 years. I graduated, or I got my PhD back in 2009. I worked like 1 year as a postdoc, then I worked for 10 years as an assistant to professor of chemical engineering, and then I decided to join WVU in the Fundamentals of Engineering program. And I've been with them for the last 4 years, almost 3.5 years. I just started, honestly, my 4th year. And today's lecture is going to be about my course that I teach in the Honors College, the course that I developed last year, which is entitled by Climate Change via Excel. I want to start with giving a context about the course, because it's very important for everybody to know where this course actually coming from, so you can appreciate the content and the title of the course. So The main idea when I was actually trying to develop the course, I wanted actually to teach the students Microsoft Excel. And I was looking for example because the main thing was Microsoft Excel. I was looking for examples, and I wanted all examples to come from within the same pool. And I was looking for a subject that is going to fit everybody at WVU. And I said, probably I'm going to look for certain topics that are going to be hot topics, contemporary topics that everybody is going to like. And I came up with climate change. So I said, okay, I'm going to teach Microsoft Excel, but every single example I will be using in the class is going to be coming from a climate change problem. But I was looking for problems. I was looking for examples. It was kind of very hard for me to fit or to adjust the Microsoft Excel functions to fit only the climate change problems. So I decided to flip actually out the title and to focus more on the climate change, but I'm going to teach the climate change. I'm going to use Microsoft Excel. So the entire idea was shifted to climate change, and the climate change topic is going to be taught through the Microsoft Excel. Okay, so this is the main thing behind the climate change through Excel or via Excel. I'm going to start with the main goals of the course, as I believe they should be. I'm going to, the main idea of the course is to help the students understand the science of climate change. So this is kind of the main thing behind the course. And then I wanted actually the students to realize this problem is a serious problem, and we should be taking steps toward actually making solutions or propose some solutions because it's a serious problem. And then the second minor maybe goal of the course, I wanted to develop the critical thinking. I'm coming from an engineering background, and we like critical thinking. And I want to make sure that the students are going at the end of the course or are able at the end of the course to criticize some of the climate change actually scenarios and problems. Okay. Going to the in depth about talking about the course is going to be mainly this course is for anyone interested to learn something new about climate change. So if you need to gain some basic knowledge in climate change, this course is the right course for you. We're not going to go in depth explaining physics or chemistry background about climate change. We're going to go to the minimum, okay? And I'm not going to ask for any prior knowledge in any kind of science. If we need physics, I'm going to teach you the required physics to understand the climate change data. If we need chemistry, I'm going to teach you the fundamentals of chemistry that you need to understand the climate change problems. I'm not going to ask for a prerequisite for this course, so anyone can take the course. However, I would like to see some student with some algebraic knowledge because it's very important, honestly, once we're dealing with numbers and equations, even though we're not dealing with complicated equations, very simple algebraic equations, but I want the students to be able to manipulate them and solve the problems. I don't have a textbook for the course. I will, every once in a while, I'll distribute a handout, and we have a lot of PowerPoint presentations, different things, but mainly whatever things you need, I'll provide you with the stuff. So you don't need a textbook. And I will be providing with some recommended books, but they're not going to be required. Okay. In terms of grading, I like the projects, and every single engineering course that I had in the past for the last 13 years had a project. However, my projects are maybe different than most maybe professors because the project I like to give, I don't like to give one title, one project, and okay, you have the project today. I will see you at the end of the semester with a completed project. I like to divide my project into a couple of deliverables. So every 2 weeks or 10 days, I have one deliverable. and we are building our understanding of the topic, our knowledge, and then like another deliverable. By the end of the semester, you have all deliverables. So if you combine them in one document, that's going to be basically your project. The only thing you have to do, maybe adding an introduction or adding a summary at the end, and you will be done. Exams, I hate exams. I have one exam because I want to test every single individual student's knowledge. It's going to be towards the end of the semester. However, it's not a final exam. We have a lot of homework problems and in-class activities. We have a problem in class. We discuss like an example, and then I give you a similar problem. You solve it, and then you upload it to eCampus so I can grade it. That's going to be considered as in-class activity. Homework problems every maybe week or 2 weeks. I give you a set of problems, a set of things to write about, and they are going to be treated as homework problems. And then I have a couple of quizzes. The class, once I talk about the content of the course, is divided into 6 different modules. And at the end of every one of them, we have a quiz, okay? And the total is going to be obviously 100. I have some limitations, honestly. This course is not a technical course. So if you're looking for advanced physics, advanced chemistry, advanced mathematical models about climate change, this is not the course for you, because everything is simple. Everything is going to be treated, and I'm going to build the students' knowledge from the bottom all the way to the top. And we are going to focus on science. I'm an engineer, and I like science. So we're going to focus on science, and I'm not going to talk about the social, the economic aspects of climate change. However, I'm going to ask the students, honestly, to write something about the impacts of climate change on our lives in the project. It's going to be maybe half a deliverable. I'm going to cover in the course, I'm going to divide, honestly, the course into 6 modules and a project. And the time that we are going to spend in explaining each one of them, honestly, is going to be different. Some of them are short, some of them are maybe long, and they require some time. But we, as I said, the main idea is to teach climate change through Microsoft Excel. So I'm going to start with defining climate, distinguishing between, for example, climate, weather, and then the climate change. And then I'm going to spend some time covering the basic Excel functions that I believe are needed in order for you to understand the problem. And then module 2, we're going to discuss the pieces of evidence that the Earth is warming. And we have a lot of pieces of evidence, and we are going to discuss each one of them. After that, when we are done, we are ready, honestly, to start with the basic physics of the climate. And we are going to develop some climate models, and I will talk more about them. Of course, once we are done with module 3, that means we are ready to discuss the greenhouse effect and what exactly we mean with greenhouse gases and why they're bad. What's the difference between a gas and another? And then we're going to talk about what exactly as humans we're doing to impact the atmosphere and what kind of activities we're doing, and those activities are wrong and we shouldn't be doing. And the last thing, we are going to talk about the rate of planet's warming, because discussing honestly maybe the evidence of warming and the physics behind the climate warming is going to show us that, okay, we've been seeing in the history that times the planet's temperature was going up and times the planet temperature was going down. So I want to see why this time, the rate of global warming is kind of is high. Okay, I want to compare it with the numbers that we have from the past and with the current numbers that we are having now. And then, of course, every single chapter or every single topic is going to be linked to the project. And once we finish the first one, for example, I'm going to ask the students to write the first project deliverable, after the second one, the second deliverable, and so on. So by the time we're finishing or we're done with the last module, we're done almost with the project. The first one is going to be the introduction to Excel. I want to make sure that the students are able to perform mainly some statistical data analysis. I want to make sure that they understand how to calculate, they understand the physical meaning, and they know how to do it in Excel. So, for example, I want them to calculate the average, the minimum, the maximum, standard deviation, and etc., different functions. And also, I want to make sure that the students can do some basic calculations. Okay. And they're able to do put some equations in Excel to get some answers. They are able to put some formulas, and they're able to get some answers before we start actually diving into the climate change data. Another important thing also I want the students at the beginning to know, because we're going to be using this a lot in the course, is how to make charts and the graphs in Excel, because this is one of the main things, and we will be plotting hundreds of plots to show how the temperature, how the amount of carbon dioxide, how the amount of methane, how changing with time, different parameters, different things. And I want to make sure that the students know how to plot and to create charts or graphs in Excel. And I want to make sure that the students are able to create a visualization. Okay? Those are the things that I would like to cover, and at least in the first maybe module. And then since one of my goals, as I said, was to develop the critical thinking way, and I want to make sure that the students at the end of the course are able to think critically of the climate change data. Every once in a while, I put a question in the course, and we spend a class or maybe half a class discussing the questions. This is one of the questions that I like even in engineering, I like the students to know the answer for. So why should we believe that the information in this course is correct? Why do we have to believe of this information? And every time I answer the question, I go with the science, how science actually produces knowledge. So I go with, okay, a scientist has an idea, and they start generating hypotheses, and then they testing them. Then they reach to a conclusion, and then if they're done, they can actually that piece of knowledge they can if they want to publish a paper. If the paper actually passes, it is published in the peer-reviewed journal articles. And then you go to the last step, which is the crucible of science. So where all the claims are replicated and their implications are tested. So that's why you should believe in science. And this is why actually you should believe in the climate change data, because every single piece of information we discuss in the course is going to be actually coming from this process. And then maybe the second thing I would like to discuss is I want to make sure, because I asked my students in this semester, at the beginning of the semester, whether they believe in climate change and whether they believe it's a problem or it's just like things are made up and there is nothing such called the climate change. There were actually most of them, I believe they were among those people who believe in climate change. But honestly, the main thing of this chapter or module number 2 is to make sure that all the students who are in the class believe in climate change through science, okay? So the first thing we're going to discuss is we're going to provide with pieces of evidence that the climate change. And the easiest one and the straightforward one is the surface thermometer network values, okay? We have, people have started actually measuring temperature since 1850. So we have about 170 years worth of data. And I think this is maybe one of the coolest thing, honestly, because we're gonna have huge Excel sheets, and we're gonna analyze the data, and we're gonna come up with a conclusion about the temperature values. Okay, so we're gonna do some calculations to get to a conclusion. I'm not gonna say the conclusion, but to get to a conclusion. And then if you are not satisfied with this, we're gonna actually compare the surface thermometer network temperature with the satellite temperature. However, the satellite temperatures are not old, so we have them for the last maybe 40 something years. The end of the 70s, NASA started actually measuring temperature through satellites. So we're going to compare the last 40 years between the surface thermometer network temperatures and the satellite temperature. If you're not satisfied, we're going to analyze some ice data, and we're going to see what kind of conclusion we get from there. If you're not happy with these three actually ways of measuring temperature or getting to conclusions, we're going to study the oceans. And also we're going to see if we can get to the same conclusion from the three previous measurements. And the last one is going to be the sea level measurement. So if you're not happy with the first four, hopefully the sea level will make you convinced, okay? So all of them, if you will be taking the course with us, all of these measurements actually lead to one thing, which is the global warming. And if you are not satisfied by five different ways, direct, indirect measurements, I think there is going to be a problem, okay? Some people actually are not convinced because, as I said, those methods relatively are new, and we don't have data for like hundreds and thousands and millions of years ago. So in order for us to get something about, we have to study the history, okay? And of course, we can go back in history. So we want to study things that are going to help us to make conclusions about history. And we are in the course, we are going to discuss ice in general, because that ice usually provide climate change dating back into time when the snow actually fell. So by analyzing data and by taking samples, analyzing them in labs, in chemistry departments, physics departments, we can actually provide information back to 2 million years. Okay, so if you're not convinced with the most recent ones, you can be convinced with the 2 million year ones. Also, we're going to analyze data from tree rings, because also trees store climate information in their tree rings. So by going and doing this analysis or physics analysis, we provide information for the past millennium. Okay. Ocean sediments, this is another way actually to measure the climate change, which ocean sediments, what we mean in ocean sediments, honestly, accumulates at the bottom of the ocean every year, like the dirt and the dust and the stuff. Also, they contain information about climate conditions at the time they were deposited, okay? They're not giving you some information about the current temperature or pressure or environmental condition. They will take you back to history, and we could actually, using ocean sediments, we were able to get information goes back to millions of years. Okay. And we're gonna study the climates over time using the current ones and the old ways of measuring temperatures and measuring the climate changes information. We come up with one conclusion that the Earth or the planet is vibrating or oscillating between ice ages and interglacial periods. So times where with large ice sheets, we call them glacial periods or ice ages, and times with large ice sheets, we call them interglacial periods. And we're gonna make this actually and produce this plot in one of the classes, maybe in 2 or 3 weeks. And we can see that we are going up and down, up and down. This is kind of warming and going down, up and down. And we are currently over here. This is actually takes us to almost like 1 million years ago, okay? So currently we are in kind of a warm region. and it's called the interglacial period. Okay, that's over here. But of course, this is kind of something we need more time in class to spend, because zooming in on or here for the last 10,000 years, we can get a lot of information for only just from this. Let me actually write this over here, this portion over here. It will provide us with different pieces of information. Again, back to the critical thinking, every once in a while, I will be putting a question, and this is another question, and I want to link the students to whatever actually people write about the climate change. So one of the questions we will discuss in class, because it's going to require a lot of time to answer, honestly, has global warming stopped? And an article was published in Fox News, and I have the date, and I have the author, and I have everything. One line in the study, they're saying, yes, the planet has largely stopped warming over the past 15 years. Data shows, okay? I want to actually show the students once it's the time for us to answer this question, that based on the information that we learned so far, you should be able to criticize this question, and you should be able to tell that this question is this piece of information is wrong. And you should be providing a lot of actually ways to prove that they are wrong, and with, of course, using scientific ways. And then, of course, once we're done and everybody in the course is convinced that we are in global warming and we should be doing something, and we are the humans to be blamed, we're going to go to the physics topic. And as I said, I'm going to start with my third main topic of the course, which is the basics physics of the climate. And in order for everybody in the class to understand the basic physics needed for us, we're going to start talking about energy, or defining energy, power, temperature, what exactly we mean in each one of them. We're going to discuss the black body radiation and emission absorption processes. We're going to also talk about how energy from sun reaches Earth, because this is very important, and we can actually draw a lot of conclusions from this. And to simplify it, we need to make a lot of assumptions. And probably if I have time, I can mention some of the assumptions. But planet or Earth or the globe is a system, okay? It's exactly as if you are taking a cup of water out of the fridge and putting that cup of water on the table. It's going to warm up, and it needs some time, honestly, to take the room temperature, okay, from like 4 degrees Celsius to 25 degrees Celsius, which is the average room temperature. The same thing with the planet. We're going to do the energy balance, simple energy balance on the planet, and of course, using some basic physics. And we're going to see the amount of energy that we receive from sun. And we're going to see also compare it with the amount of energy that is going to emit from Earth. And we're going to see if the amount of energy is going to be more or less, because based on that, we're going to looking at the temperature. If we have more energy coming in, that means the planet temperature is going to go up. If we have more energy, we're losing more energy than the energy coming in, that means the temperature will be decreasing. And if we have the same amount of energy, of course, the temperature is going to stay the same. Of course, based on the simple physics that we will discuss, we will start creating simple climate models, because we want to understand why we're getting warmer and warmer, okay? We'll start with zero layer model. So in this model, we're going to assume that we have no atmosphere. Of course, this zero layer model, the 1, the 2, and I'm going to mention in my following slide, all of them depend on certain assumptions. And usually I have to list the assumptions before actually talking about any one of them. And usually they're valid and simplifying the problem, okay? If we do the simple physics, we get to the one main conclusion, which is the planet Earth should be based on our assumption, based on our simple climate model. it's going to be negative 18 degrees Celsius. Where in fact, we know by the information that we analyzed in chapter 2 that the average global temperature is 15 degrees. Okay, I'm giving you some secrets. So there is something wrong. It can't be like the actual temperature 15 degrees Celsius and the one we're getting from the model negative 18 degrees Celsius. There is something wrong, okay? And obviously, we can't assume an atmosphere, we can't assume the model with no atmosphere. We have to have an atmosphere. So let's take it one more step. Okay, we assume that we have the Earth and we have one layer of atmosphere. So we have an atmosphere over here, and this is the planet Earth. So this is Earth, and this is the atmosphere. Okay, we get the energy from sun, and if you see that we have an atmosphere or one layer of atmosphere, and this atmosphere actually, based on the assumption that we assumed at the beginning, is going to absorb some of the energy that is coming from the sun. In particular, it's going to absorb the infrared rays, and it's going to act as a black body. So it's going to reflect some energy back to the space, and is going to reflect some energy back to the Earth. And this is actually what causes the planet to warm up, okay? So when we do the analysis over here, when we do simple energy balance, we get the temperature to be 30. And we know from chapter 2, again, it's the average temperature of the planet is 15. And now we're getting 30. So this is at least 15 degrees warmer. So why is that? Because of the atmosphere and of the global warming. We're not convinced with one layer model. We're going to go to 2-layer model, and we do the same basic physics, and we get 62. And by going actually to the 3rd model, to the 4th model, to the N model, we can get to one conclusion that the more atmosphere layers you add, the warmer the planet will be, okay? So we're getting warmer and warmer. So obviously there is something in the atmosphere is causing the planet to be heated. What is this thing? Is the greenhouse gases, okay? The presence of greenhouse gases. They are the gases that absorb infrared photons, okay? In this module, we have to distinguish between the 2 types of gases, the greenhouse gases and the non-greenhouse gases. And non-greenhouse gases, we're not going to talk about them. Honestly, we're going to mention them, but they're not important because they're not linked to the problem. So the most important greenhouse gases are the water vapor, carbon dioxide, and methane. And we're going to spend a lot of time, honestly, analyzing the carbon dioxide because it's kind of the main one. And then we're going to spend maybe a class or less explaining the methane. But we're not going to spend any time, honestly, talking about the water vapor because in a way or another, we do not actually control the amount of water vapor in the planet because they are controlled by the amount of evaporation and condensation, okay? If you want to argue, yes, we can control them because if the planet is warming, that means the temperature is increasing. That means the amount of evaporation is going to be increased. But that's, in terms of science, is not going to be, honestly, under the main effect. Is going to be under the kind of feedbacks, okay? Then carbon dioxide and methane are the key greenhouse gases. We do the carbon cycle, basically how carbon moves between the atmosphere, ocean, land, biosphere, and rocks on Earth, because this is very important. And if you look at this actually diagram, and we're going to spend a lot of time actually doing this in class, we're going to see that everything is balanced. Like nature is, everything in nature is balanced by we have a certain amount of carbon in the atmosphere. It's about 864 gigatons carbon, and that is balanced with the amount that we have in In the land biosphere, we have about 2,000 gigatons of carbon, and they are balanced, 110 going to the atmosphere, and we have 110 per year coming back to the land biosphere through the photosynthesis process and the respiration, okay? And then we have also the amount of this is the amount of carbon that we have in oceans, and usually oceans in terms of climate change are considered or consist of two layers. The first 100 meter in the ocean, it's called the ocean mixed layer, and contains about 900 gigatons of carbon. And then if you go down to the deep ocean, we have about 37,000 gigatons of carbon. As I said before, they are balanced. We have 60 gigatons per year going to the atmosphere from the ocean back to the ocean, and we have about 100 gigatons of carbon per year going between the first or the mixed layer of oceans to the deep oceans. Okay, this is perfect. This is how the carbon cycle actually works. Nothing is wrong. Okay, and we have another thing, which is the amount of carbons that we have in rocks. And we have millions and millions of gigatons of carbons, and we have about 0.1 going to the atmosphere and 0.1 gigatons per year going back to rocks. Okay, the rocks, we have volcanic eruptions, so that's producing tons of carbons per year into the atmosphere. And then we have another process actually, which is the carbon dioxide with rain will be shifted or reacted to convert something, the calcium carbonate, if you know some chemistry. If not, we'll talk about it in class, and we'll go back down to deep oceans, okay? Again, so far as everything is perfect, everything is balanced, and we have no problems until to the point that humans started actually interacting and interfering with the environment. And we have, this is the problem, we have 8 gigatons of carbon produced from fossil fuels. And those are not balanced with anything, and they are just dumped to the atmosphere, and we're having more and more and more of carbon dioxide every single year. So, we'll, of course, we'll spend a lot of time actually doing and talking about this and making sure that the steps that we should be doing in order for us to avoid using more fossil fuels. The other one is the other greenhouse gases. The second and most important one is the methane. Again, well, it's less dangerous than carbon dioxide. Usually we have it not through, we have some of it through the fossil fuels, but mainly I would say 60% is coming from agriculture, livestock, some bacteria, some rice productions. We have about maybe 30% something coming from petrochemical processes, and maybe about 10% or less or more some coming from burning forest and other biomass sources. Okay. So also one of the main thing I would like the students to appreciate the course and to understand the consequences of whatever things we're doing nowadays is to see that the difference between carbon dioxide and methane. We're going to also produce this plot in class. If you actually have a dose of carbon dioxide and a dose of methane injected to the atmosphere now, we can see from this plot, actually you need 10,000 years to get almost to 10% of to remove 90% basically of the carbon dioxide. Okay, so you need 10,000 years. However, if you just injected a dose of methane, you need about maybe 60 years something or 50 something years to remove the methane from the environment. You see kind of the difference between carbon dioxide and methane, and the students are going to hopefully take care of the stuff, maybe at least in engineering. This is what kind of most of the time I tell the students that you should be taking care of the environment by making sure that the things that you will be designing in the future are not going to produce carbon dioxide or methane. The last thing in the course is going to be going back to the physics models, because if I want to go back to the climate change problem and how to do the energy balance, and when I said if you take a cup of water, actually put it out of the fridge and put it on a table, it doesn't go actually instantly to room temperature. It will take maybe, I don't know, it depends on the quantity of liquid water you put in the cup, but it will take a couple of minutes, a couple of seconds to warm up. And the same exact thing would be happening in the planet, okay? If we have a lot of carbon dioxide pumped to the atmosphere, and it's going to be, we need 10,000 of years to remove it, and we are going to be globally warmed, and we're not going actually to, the temperature is not going to go up in 1 or 2 days, okay? And again, I'm going to produce these plots with the students. Let's assume that we had some changes to the environment at year 0, and we need actually almost like 20,000 years to go back to get to the equilibrium. And this is kind of one main things also I want the students to be aware of, because whatever things we're doing right now, we're not going to be suffering from them, okay? People who are going to come after us, maybe in 1,000 or 2,000 years, are going to suffer. So we're making the problem, but they are going to suffer. Again, back to the critical thinking thing, if you have arguments that you would like to with some skeptical people, I'm kind of every once in a while I put some questions. Probably you will see some questions, and a lot of people will say, how do we know that the combustion of fossil fuels is responsible for the increase in carbon dioxide rather than non-human sources such as volcanoes or plants? Of course, in order for us to answer the questions, we have kind of to go study some basic chemistry, talk about isotopes and stuff like this, to convince my students, and then the students can convince the other people. Another good question I'm planning also to share with the students: why focus on carbon dioxide from fossil fuels combustion when planets and animals actually emit far more carbon dioxide to the atmosphere? Again, back because the carbon dioxide that we will be producing from fossil fuels is not going to be balanced by anything else. So we're not shifting between the atmosphere, oceans, or the land and the atmosphere. We're just dumping CO2 to the environment. The impact of the climate change, I'm going to actually let the students honestly discuss this thing in their projects. What does rising sea levels mean to us? Can we accommodate this? What does melting glaciers mean? Right now, we're experiencing a lot of extreme weather events and wildfires. Hurricanes are very intense nowadays. So I'm going to let the students honestly, based on the knowledge that they acquired in the course, they should be able to answer questions like this and things that we should be doing in order for us to kind of find solutions. So also, this is a part of the project. I want to make sure that the students, based on the problem, based on the numbers that we got in the course from the first plot we had in the course to the last one, to draw a conclusion from there. And I want to make sure that is there a way that for human beings to adapt to climate changes or not? And I was just going to make a call to action, and I want to make sure that the students by the end of the course are aware of the problem, and they have some physics, science knowledge of the topic, and they have some tools to hopefully to help solving the problem. And thank you so much for listening and for coming this evening. And I think the floor now is open for questions if you have any.
Yes, thank you. Thank you, Dr. Almasri. If you can unshare your screen.
Absolutely.
And, I see Ben Golden has his hand up. So Ben, if you want to type in your question in the Q&A, or anybody who has questions. Let's open up the floor for questions now. Anybody has questions for Dr. Almasri? Very informative presentation, by the way. I enjoyed it. I learned a few things about.
Thank you.
Okay, I do see a question. Okay. You said no. You said no prerequisites, right?
Yes, that's correct. Would explain whatever physics, math, chemistry we need. I'm going to start from like the bottom, and I'm going to go up with you.
Okay, thank you. Someone said, is this class, this is probably, I can answer this. Yes, the class would be offered in the spring semester. We probably only be having one section of it in the spring semester. Other questions, students, or anyone, because I assume there may not be students on here. Okay, let's see. Where will this class be offered? I feel like I can't remember what you submitted. I feel like it's on Evansdale somewhere. I think it's in Evansdale.
Yes, I like the classrooms to be around me because I have the classes before and after, and I don't like to go to different campuses because that's going to take like an hour to go and come back. And on top of that, also, I like to have a computer lab because we will be using Microsoft Excel. So I know our labs or the classrooms in the engineering, they have computer labs or computers.
Okay. This is a good one here. If I took the, I guess, Foundations of Engineering Program Excel Focus class last year, will this class be still worth taking?
Absolutely, because the Excel portion of this course is going to be done in five classes, and the rest of the semester will be covering information about climate change.
Okay, good question. Some pretty some good informational questions being asked. I appreciate these questions.
That's good.
Do we have any other questions for Dr. Almasri? Going once, going twice. Yep, I don't see any more questions for Dr. Almasri. So thank you very much. We appreciate your time, Dr. Almasri, the opportunity to visit with you this evening. Students, if you are interested in taking the course and you have questions to Dr. Almasri, please feel free to reach out. His email is atheer.almasri@mail.wvu.edu. An archived version of this webinar is going to be placed on our Honors College website. Thank you for spending the evening with us, and everyone have a good evening. Dr. Almasri, thank you very much again. This
Thank you so much for having me. Thank you.
Presentation. Everyone have a good evening.
Thank you.
Bye-bye.